Hi all, very happy morning to each and every enrolled students from CAT Achievers batch. Today it is going to be a very important session on factors and multiples. Factors and multiples. The first session, I'm going to discuss everything in detail. I'm going to spend a lot of time on each and every concept. This one chapter, which involves a lot of teachers' intervention. But before we start the class, let me see whether everything is perfect. Then we will start the class. Very important class. Just give me 1 minute, sir. Just give me 1 minute. Let me check whether everything is proper. Kindly reply it in the comment. Praveen, please open the comment one. Let me see if I can see the comments. I'm not able to see the comments right now. Just 1 minute, sir. Factors and multiples. Very important topic. Very interesting concept. This is one topic which involves a lot of sub-concepts. Factors and multiples. Factors and multiples. Before I start the class, I have few suggestions to each and every student. Kindly sit in the class with a notebook and a pen. Kindly sit in the class with a notebook and a pen. Watch the entire class. Kindly do not skip in between. Watch the entire class. Watch the entire class. And this one such a topic, kindly revise it in next 24 hours so that you will not miss out any important concepts. Kindly revise the entire class within 24 hours. Within 24 hours. 1 minute, sir. Comments I'm unable to see. Close it and make the video. Comments I'm unable to see, so will not spend any time in terms. If any student I got any doubts, I'm always available in Telegram group. In case you are an enrolled student, you got any doubt, do not hesitate to keep your doubts in the Telegram group. Do not hesitate to keep your doubts in the Telegram group. Watch the entire class. Maybe I might take the class 3 hours to complete the concepts. 3 hours to complete the concept. Very important concept. What are the concepts that we are going to learn? What are the concepts that we are going to learn? First is introduction to factors, introduction to multiples, and all the other models related to factors. Close to about 8 to 12 concepts are there related to factors, which includes finding the number of factors, finding the number of odd factors, even factors, factors which are perfect squares, factors which are perfect cubes, factors which are multiples of k, how many distinct factors which are co-prime to each other. Factors we will discuss 8 to 12 concepts. Then we will discuss sum of factors, 4 to 5 concepts, product of factors, 4 to 5 concepts, These are all the concepts which we are going to discuss today. 4 to 5 concepts. And the next one, some miscellaneous concepts. What if the number is a perfect square? What will be the behavior of the number of factors? 3 to 4 concepts. So in total, almost 20 to 25 concepts you are going to learn in the next 3 hours of the class. Class will be very intense by nature. Class will be extremely conceptual class. We will understand the concept and will create as many questions as possible. These are the concepts which we are going to learn. factors, sum of the factors, product of the factors, miscellaneous problems, 3 to 4 concepts. Generally, factors and multiples. Factors and multiples. I need close to about 6 to 7 hours. So we will divide it into 2 or 3 sessions. Session 1, 2, in case if we cannot complete it in session 2, we will take it in session number 3. Session number 2 and session number 3 are advanced level, cat level concepts. As you know, in every class of mine, first I will start with the foundation level problems. Foundation level problems. Then I will talk about intermediate level problems. In the first session, only we will discuss foundation level problems and intermediate level problems. In the advanced level session, which I am going to discuss in session number 2 and session number 3. Session number 2 and session number 3. These are the things. I hope the concepts are, what we are going to learn is very, very clear. Kindly tell the world that you are going to get into a study mode. Keep all your distractions away. Keep all your distractions away. I'm going to give a lot of assignments related to every concept that I discussed in the regular class so that you can practice it. You do not need any other material for you to revise. I will give you enough solved problems in the class and enough assignment in the problems which are very, very close to the management examination level. If you solve it, you are almost very comfortable with each and every concept. Another important key point, another very, very important key point. Republic Day, January 26th. Republic Day, January 26th. I will be taking 6 hours classes. 6 hours classes I am going to take, and the classes will be from 9 to 11 p.m., 11 o'clock in the morning, 9 to 11. Then I will be taking 12 to 2, and then I will be taking 3 to 5 p.m. All the classes will be on ANIL NAIR classes YouTube channel. In case if you are not subscribed to it, kindly subscribe it. Subscribe the channel, ANIL NAIR classes YouTube channel. January 26th, Republic Day, we will have 3 sessions, each session of 2 hours. The timing will be from 9 to 11 o'clock, 12 to 2 p.m. and 3 to 5 p.m. 9 to 11, 12 to 2, 3 to 5 p.m. We will be covering the advanced sessions. The reason why I am taking the 6 hours is, in the Saturday and Sunday, I will discuss the basic and foundation related problems, and you will revise these foundation level problems till Monday night. Tuesday, when you are sitting for an advanced level sessions, we will be solving as many problems as possible because you are extremely comfortable with this concept. 9 to 11 p.m., 12 to 2 p.m., 3 to 5 p.m. Remember, especially in case if you are an enrolled batch with me, forget about public holidays, forget about government holidays. Most of the time you will have at least 1 or 2 sessions, unless and until I am sick. Most likely in my last 15 plus years of experience, class postponed will not happen unless and until because of medical reasons. These are we are going to discuss. Kindly sit in the class with a notebook and a pen. Each and every slide, I am going to discuss a particular concept, and the notes will be available in the note section of our enrolled batch. Let us start the class. I hope everything it is clear. Tomorrow, 26th, Republic Day, extra session schedule. What is that you are going to learn? Now, please write down. Write down. Factors and multiples. Factors and multiples. In this slide, we are going to discuss what is a factor, what is a multiple, and mathematical definition related to factors and multiples. Factors and multiples. Factors and multiples. The first thing, for example, if I take 12, what are the factors for 12? What do you mean by factor for a number? Suppose n is a natural number. N is a natural number. This natural number is divided by an another natural number. N is divided by x. Remainder is 0. If a natural number is divided by another natural number and the remainder is 0, then x is said to be a factor of n. Then x is said to be a factor of n. Or in other words, n is said to be a multiple of x. Both the ways you can do it. Numerator can be called as a multiple of denominator, or denominator can be called as a factor of numerator. When you divide a natural number by any other natural number, if it is perfectly divisible, when I say perfectly divisible, all these key points are very, very important. When I say it is perfectly divisible, that means the remainder will be 0. When you divide numerator by denominator and the remainder is 0, that means the denominator perfectly divides the numerator, or the numerator is perfectly divisible by denominator. I hope the mathematical definition for factors and multiples is crystal clear to you. When n is divided by x, remainder is 0. Denominator is called a factor of numerator and the numerator is called a multiple of denominator. Now, 12 divided by x, I want the factors. 12 divided by x, remainder should be 0. Now, first we will write all the natural numbers less than or equivalent to 12. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. What are all these? These are all the values of x less than or equivalent to 12, out of which whatever that gives a remainder, that is called a factor. 12 by 1. 12 is perfectly divisible by 1. 1 is a factor of 12. 12 by 2. 12 is an even number. Even number is perfectly divisible by 2. 12 is a multiple of 3. Perfectly. 12 is a multiple of 4. 12. 5 is a prime number. 12, if a numerator has to be divisible by 5, unit digit has to be 0 or 5. Not possible. 6, it is divisible by 2 and 3. So 6 will come. 7, 12 is a composite number. 7 is a prime number. 12 is not divisible by 7. 12 is not divisible by 8. 8 ones are 8. 8 twos are 16. 9 ones are 9. 9 twos are 18. 10 ones are 10. 10 twos are 20. 11, no. 12, yes. So out of all the natural numbers less than or equivalent to 12, there are only certain numbers. When you divide 12 by that numbers, the remainder is 0. What are that numbers? 1, 2, 3, 4, 6, 12. 1, 2, 3, 4, 6, 12. Now what are we doing in this case? I am writing all the values and I am going step by step. If instead of 12, if it is 100, I have to write all the natural numbers less than or equivalent to 100 and I have to check which number divides 100, which will be a very, very tiresome process and which will be a long method to do it. This is a generic way to find the factors of a number, writing all the natural numbers less than or equivalent to numerator and checking which one will perfectly divides. It will be extremely time consuming. It will be extremely time consuming. So is there any better way to find out the factors? Now see here. Suppose all the numbers, the domain of all the questions that we are solving is from natural numbers. Natural numbers starts from 1. If I take 12, from numbers less than or equivalent to 12 till 1 I am taking. So there is a lower limit and there is an upper limit. Lower limit for natural numbers, it is 1. Upper limit is the number itself. There are certain numbers which are lying from 1 to 12. So factors we will have a range. Multiples, when I say multiples, 12 twos are 24, 12 threes are 36, 12 fours are 48, 12 fives are 60, 12 sixes are 72, and it keeps on going. Lower limit it is 12. Upper limit we don't know. The largest natural number is countable infinite. 12 multiples can go to any number of times. If there is an upper limit, I would have got a range for multiples. So that is the reason we will concentrate on the factors of a number which will give a range. which will give a range. I hope the idea it is clear. So the same question can be asked. Suppose a question based on the definition of a perfect square. Reminder 1, n square plus 7n plus 12 divided by n, it is 0. N square plus 7n plus 12 divided by n, it is 0. N is a natural number. N is a natural number. The question can be asked like this. N is a natural number. How many values n can take? How many values n can take? N square plus 7n plus 12 divided by n, remainder is 0. When numerator is divided by denominator, remainder is 0. That means denominator, it is a factor of numerator. N square by n, it is n. Natural number 7 plus 12 by n, it should be 0. This is a natural number, this is a natural number. 12 by n, if it is n is a factor of 12, then the remainder will be perfectly 0. So n can be 1, 2, 3, 4, 6, 12. This is how the questions in the CAT level can be asked instead of asking you the factors of 12. I hope it is clear. N square, it is perfectly divisible by n. N square, it is perfectly divisible by n. Remainder 0. 7, n is perfectly divisible by 7. Remainder 0. That means first term, n square is divisible by n. We will write it like this. N square, it is perfectly divisible by n. 7n is perfectly divisible by n. That means 12 divided by n. Remainder should be 0. When 12 divided by n, remainder, it is 0. That means n should be a factor of 12. 1, 2, 3, 4, 6, 12. Slide number 1 focuses on the definition of factors. This is the definition of factors. Factor definition. This is the definition of factor and this is the definition of a multiple. In slide number 1, we have seen the definition of factor and multiples. Factor and multiples. Now see here. Now in this slide, we are going to discuss. Suppose I took a number n equivalent to 360. N equivalent to 360. Write down in the same way whatever I am telling. Whenever there is a natural number given in the question. Whenever there is a natural number given in the question, whenever there is a natural number given in the question, write the natural number as a power of prime numbers. As a power of prime numbers. Every natural number can be written as a power of prime numbers. 6 can be written as 2 into 3. 12 can be written as 2 square into 3. 5 can be written as 5 power 1. Prime number is the basic number. Composite number is derived from prime number. Composite number is derived from prime number. So, in case if there is any natural number given in the question, the first thing you should do is decompose the number as a power of prime numbers. How to decompose it? The one method is divided by the prime numbers. 2 180s are 360, 2 90s are 180, 2 45s are 90, 3 15s are 45, 3 5s are 15. So 360 it is. 2 came 3 times, so it is 2 cube into 3 square into 5 into 3 square into 5. 2 cube into 3 square into 5. I hope it is clear. Now, find the total number of, three questions we will solve. One is find the total number of factors for this number. Find the total number of prime factors for this number. Prime factors for this number. Find the total number of composite factors for this number. Find the total number of composite factors for these numbers. When I say factors, that factors include factors which are prime numbers, factors which are composite numbers. First, I need to find the total number of factors, total number of prime factors, total number of composite factors. These three we will discuss. But before we discuss these three, first we have to discuss How to find out the number of factors? Let us take a smaller number. Smaller number, it is 12. 12 is a composite number. Write the number as a product of prime numbers. 2 square into 3 power 1. Whenever you get a composite number, write the number as a power of prime numbers. Always write the number as a power of prime numbers. 2 square into 3 power 1. Now see here. Let me take all the powers of 2, starting from 0, 1, 2. 2 power 0, 2 power 1, 2 power 2. Write down all the powers of the next prime number, starting from 0 to 1. 3 power 0 and 3 power 1. 3 power 0 and 3 power 1. Why are we taking all the powers of 2 and 3? Now see here. 2 power 0 into 3 power 0. 2 power 0 into 3 power 0. 1 into 1. 1, it is a factor of 12. Are you all with me? Next one. 2 power 0 into 3 power 1. 1 into 3. 3 is a factor of 12. 2 into 1. 2, it is a factor of 12. 2 into 3. 6, it is a factor of 12. 4 into 1. 4, it is a factor of 12. 4 into 3. 12, it is a factor of 12. In case if you want to enumerate the total factors of 12, step number 1, write the number as a power of a prime bases. Write all the powers of a first prime base, starting from 0 to the highest power. Why we are taking from 0 to highest power? 2 power 0. 1 is a prime number. 3 power 0, it is also a prime number. So, 2 power 0, 1 is a number which will divide every other number. 3 power 0, 1 is a number which will divide any number. In this number, there are some prime numbers, composite numbers. If you see, 2 is a prime factor. 3 is a prime factor. 4 is a composite factor. 6 is a composite factor. And 12 is a composite factor. 1 is neither prime nor composite. 1 is neither prime nor composite. That is the reason 3 cases. So how many factors will be there? From 0 to 2, 3 cases. From 0 to 1, 2 cases. Totally, how many factors are there for this number? 6 factors are there. How to find out the total number of factors? Start from the power 0 for the first prime number. Write down till highest power. 0 to 2, 3 cases. 0 to 1, 2 cases. 3 into 2. Total, how many factors are there? 6 cases. Write the number as a power of prime numbers and decompose it from 0 to the power. I hope the idea it is clear. No formula usage. I am not going to use a single formula in any of my class, and I am going to solve each and every problem logically. Each and every problem logically. How to find out the total number of factors? How to find the total number of factors? Start from 0 to the highest power for the first prime base, 0 to 3. In the next problem, we will avoid writing it. Then from 0 to 2, then from 5 power 0 to 5 power 1. 0 to 3, how many combinations are there? 4 combinations. First I will take power of 2, then I will take power of 3. 0 to 2, how many cases are there? 3 cases. 0 to 1, how many cases are there? 2 cases. 4 into 3 into 2. 4 into 3 into 2. What will be the answer? 24. I hope the idea it is clear. First write down this number as the power of prime bases. 0 to 3, 4 cases. 0 to 2, 3 cases. Sir, why into came here? If you are doing one event after another event, if you are doing one event after another event, then it is into. One event after another event, it is into. Please write down one point here. Whenever there is a choice, whenever there is no choice, it is nothing but an and condition. I have to use fundamental principle of multiplication. Whenever there is an or condition, it is plus. I will discuss this in permutation and combination. All the powers of 0 to 3 should be taken. All the powers of 0 to 2 should be taken. All the powers of 0 to 1 should be taken. To get factors, 4 into 3 into 2, total answer is 24. Total answer is 24. Prime factors, now see here. Wherever the answer is there, I will use red color. Prime factors, what do you mean by prime factors? Read the statement again. Prime factors. Prime factors means factors which are prime numbers. Factors which are prime numbers. Factors which are prime numbers. Prime factors means in 360 there are certain factors which are prime numbers. How to find out the prime number factors? Now see here. Suppose if I take total cases, 2 power 0 to 2 power 3, 3 power 0 to 3 power 2, 5 power 0, 5 power 1. Here I will write 2 power 1 and 3 power 1. Now see, 2 power 0, 1 is neither prime nor composite. 1 is neither prime nor composite. 1 is neither prime nor composite. So 2 power 0 into 3 power 0 into 5 power 0. I will get 1. 1 is neither prime nor composite. 2 square, it is 4. 2 cube, it is 8. Both are composite. Any power of a prime number beyond 2. Any power of a prime number beyond 2. We'll write down in bracket. Not a single key point. We will miss it. Any prime number, power greater than or equivalent to 2. It is a composite number. It is a composite number. 3 square, it is 9, composite. 5 square, 25, it is composite. 3 cube, 27, it is composite. So, for me, I require the prime factors. Prime factor means factors which are prime numbers. So, 1 is neither prime nor composite. 2 square out, 2 cube out. 3 square out. So, how many I got? 2 power 1, 3 power 1, 5 power 1. Even if you multiply also, 2 into 3, 6. 6 is a composite number. 2 into 5, which is a 10, composite number. 3 into 5, 15. It is a composite number. So when I say factors which are prime number, it is nothing but total number of prime bases. Total number of prime bases. Total number of prime bases. How many prime bases are there? 2, 3 and 5. So answer for this question is 3. Answer for this question is 3. Answer for this question is 3. What do you mean by factors which are prime numbers? Factors which are prime numbers means that number should have only 2 distinct factors. 2 power 0, 3 power 0, 5 power 0. Out. 1 is neither prime nor composite. 2 square. Every prime number greater than or equivalent to 2. It is composite. 2 square out, 2 cube out. 3 square out. So remaining it is 2 power 1, 3 power 1, 5 power 1. So there are no combinations. 2 into 3, 6 is a composite number. 2 into 5, 10 is a composite number. 3 into 5, 15, it is a composite number. So when I need prime factors, all I need to do is count the total number of prime bases. 2, 3 and 5. There are 3 prime bases. Every prime number power 1, it is a prime number. 2 power 1, 2, it is a prime number. 3 power 1, 3, it is a prime number. 5 power 1, 5, it is a prime number. Composite factors. How to determine the composite factors? Now see here. How to determine the composite factors? Very, very important key point. 1 is neither prime nor composite. 1 plus prime factors. 1 plus prime factors plus composite factors. 1 plus prime factors plus composite factors will be equivalent to total number of factors. When I say, just think logically, what is a natural number? Natural number is the set of all the numbers starting from 1. In that 1 is neither prime nor composite because 1 has got only one factor, 1. Prime number has got only 2 factors. Composite number will have greater than or equivalent to 2 factors. So just attach factors. Total factors is 1 plus prime factors plus composite factors. I require composite factors. Total factors, how much I got? 24 minus of 1 plus 3. 24 minus 4. Total number of composite factors will be 20. Total number of composite factors will be 20. Very, very good question. Introductory problem which explains 3 important concepts. How to find out the number of factors. How to find out the number of factors. In case if you want to find out the number of factors, write from power of 0 to 3, 4, 0 to 2, 3, 0 to 1, 2, 4 into 3 into 2, it is 24. Prime factors are the factors which are prime numbers. Every prime number power 1 or it is equivalent to the total number of prime bases. Prime bases 3 are there, 2, 3 and 5. Composite factors. One is neither prime nor composite. One is neither prime nor composite. A composite number is a number which has got greater than or greater than 2 factors. Prime number has got only 2 factors. Only 2 factors. Composite number beyond 2 factors. One is neither prime nor composite. One is neither prime nor composite. So the first one answer is 24. Prime factors it is 3 and composite factors it is 20. 20 plus 3, 23 plus 1. It is nothing but total number of factors. It is total number of factors. It is total number of factors. 2 questions which we will solve. 2 questions which we will solve. Question. First question. First one. N equivalent to 15 square into 8 cube. Find the total number of each and every model I will discuss in detail. Find the total number of. Find the total number of. First one, factors. Second one, prime factors. Second one, prime factors. Third one, composite factors. Third one, composite factors. Mistake a student may do is 3 into 4, 12, you might do it. 15 and 8 are composite number. The first step whenever we need to find out the number of factors is decompose the number as a power of prime basis. Prime basis. So solution, N is 15 square into 8 cube. 15 it is 3 into 5 square. 3 into 5 square. 8 it is 2 cube power 3. So 3 square into 5 square into 2 power 9. This is N. Always decompose the number. Always decompose the number as a power of prime basis. Now factors will be 2 power 9. 0 to 9 there will be 10 cases. 0 to 2 there will be 3 cases. 0 to 2 there will be 3 cases. 10 into 9. The total number of factors for this number will be 90. From where we got these 10? 10 is nothing but 2 power 0 to 2 power 9. 0 to 9. 3 square. Why we got 3? 3 power 0 to 3 power 2. 5 power 0 to 5 power 2. 10 into 3 into 3. 90. I hope it is clear. Factors will be 90. Prime factors. What do you mean by prime factors? Factors which are prime numbers. How many prime bases are there? Which is 3. Which is 3. Composite factors will be 86. Reason 1 plus prime factors. 1 plus prime factors plus composite factors. 1 plus prime factors plus composite factors is equivalent to total number of factors. It is equivalent to total number of factors. It is equivalent to total number of factors. I hope the idea it is clear. 1 plus prime factors plus composite factors is equivalent to total number of factors. 1 plus 86 plus 3. Answer is defined as 90. Next question. See here. Next question. Prime factors. Prime factors. There are three. Prime factors. There are three. Composite factors. Composite factors. Composite factors. And the total number of factors. And the total number of factors. If it is 5. Prime factors, it is 3. Composite factors, it is 5. Find the total number of factors. 1 plus prime factors plus composite factors. Total number of factors, it is defined as 1 plus prime factors plus composite factors. It is 9. It is 9. I hope the idea it is clear. If the prime factors, it is 3. Composite factors, it is 5. Total number of factors will be 1 plus prime factors plus composite factors. 1 plus 5 plus 3. It is 9. Next key point. Please write down. Two important key points. Now we will just highlight all the answers. Here factors, it will be 90, prime factors 3, composite factors 86, 1 plus prime factors plus composite factors, it is total factors. Key point. The first key point. Suppose if P is a prime number. P is a prime number. P is a prime number. How many factors it will have? Only 2 factors it will have. What are the 2 factors for a prime number? P power 0 and P power 1, which is 1 and P. 1 and P. I hope it is clear why prime number has got only 2 factors. Every prime number starting from 0 to the prime number highest power we have to write. P power 0, P power 1. Suppose if I take a square of a prime number. A square of a prime number. A square of a prime number. For example, 3 square, 9. How many factors are there? 3 power 0, 3 power 1, 3 power 2. Yes or no? Suppose if I take 7 square, 14, 9. 7 power 0, 7 power 1, 7 power 2. How many factors are there? 3. A square of a prime number has got only 3 factors. What will be the natural numbers? What will be the numbers which has got only 3 factors? The numbers which has got only 3 factors are nothing but the square of a prime number. A square of a prime number will have only 3 factors. A prime number will have only 2 factors. Only 2 factors. Why? The proof is also clear. P power 0, P power 1. 2 factors. P power 0, P power 1, P power 2. 3 factors. Next question based on this. How many natural numbers? How many natural numbers? How many natural numbers less than 50? How many natural numbers less than 50 has only 2 factors? We discussed the concept. Now let us discuss the examples. Only 2 factors. Next one, only 3 factors. Only 2 factors and only 3 factors. Just now we discussed the concept. What will be the number which has got only 3 factors? It is defined as a square of a prime number. It is defined as a square of a prime number. Square of a prime number. Let us write down what will be the squares of a prime number. The lowest prime number, it is 2. 2 square, 3 square, 5 square, 7 square. Next it is 11 square. But the upper limit, the natural numbers we require less than 50. So 11 square can be eliminated. How many natural numbers will have exactly 3 factors or only 3 factors? The answer will be 4. What will be that 4 numbers? 2 square, 3 square, 5 square and 7 square. 2 square 4, 3 square 9, 5 square 25. What are all the natural numbers? 4, 9, 25. and 49. These are the four natural numbers which will have exactly three factors. Exactly three factors. Now, the first question is very easy. How many natural numbers less than 50 has only two factors? The natural number which will have only two factors are called prime numbers. Are called prime numbers. Are called prime numbers. From 1 to 50. From 1 to 50, there are 15 prime numbers. From 1 to 50, there are 15 prime numbers. I hope the idea it is clear. So answer for this question is 15. Answer for this question is 15. Concept by concept. Each and every concept we will discuss, then we will take up a problem. I hope this concept it is clear. Square of a prime number has exactly three factors, and a prime number has only two factors. And a prime number has only two factors. Now, next two questions. How many factors are common to 360, 540? How many factors are common to 360, 540? Next question. How many factors for 360? How many factors for 360 are not factors of 540? How many factors for 360 are not factors of 540? Are not factors of 540? These two questions will solve. How many factors are common to 360 and 540? He is telling 360 write the factors, 540 write the factors. Take the factors which are common to 360 and 540. List that items. How many factors for 360 are not factors of 540? One by one we will discuss the concept. Now see here. Concept. With an example. Suppose if I take 6, smaller number we will take. What are the factors of 6? Factors of 6 are 1 is a factor of 6, 2 is a factor of 6, 3 is a factor of 6, and 6 is a factor of 6. Yes or no? Let me take 9. What are the factors of 9? 1 is a factor of 9, 3 is a factor of 9, and 9 is also a factor of 9. 1, 2, 3, 6 are factors of 6, 1, 3, 9 are factors of 9. I want factors common. I want the factors common. I want the factors common to 6 and 9. What are the factors common? 1 is common to 6 and 9. 2 is not common to 6 and 9. 3 is common to 6 and 9. 3 is common to 6 and 9. 1, 3. These are nothing but the factors for 3. These are nothing but the factors for 3. So whenever we want the HCF factors common to 6 and 9, we will take the HCF of 6 and 9. Why we got HCF of 6 and 9? Highest common factor. Why we are taking? In the name itself it is present. HCF, factors common. In that one, highest number will become the highest common factor. So whenever we are listing all the factors, everything will come. So first write down the factors common to 6 and 9. Factors common to 6 and 9 are 1 and 3, 1 and 3. 1 and 3 are nothing but the factors for 3. 3 is defined as the HCF of 6 and 9. 3 is defined as the HCF of 6 and 9. So whenever, immediately it should strike you. Whenever the wording is factors common to, whenever the wording is factors common to, we have to take the HCF. One is 360. Another is 540. Another is 540. Another is 540. 360 it is 180 into 2. 540 it is 180 into 3. 180 into 3. 180 into 3. Now see here. HCF of 360, 540. 360, 540. 360, what is the factor common to both 360 and 540? Highest. 180 into 2, 180 into 3. 180 is common, take it out, 180. 2 and 3 are coprimes. 2 and 3 are coprimes. Write down one important key point. HCF of coprimes, it is always 1. So 180 is taken out, remaining 2 and 3 are coprimes. Anyway, in tomorrow's class, HCF I am going to discuss in detail. 180, 180. So it is 180. It is 180. So what are the factors for 180? 180 is can be written as 2 square into 3 square into 5. Are you all with me? 2 square it is 4. 3 square it is 9. 5 power 1 it is 5. 4 9s are 36. 36 5s are 180. How many factors are there for 180? How many factors are there for 180? 2 square it is 3. It is 3 square it is 3. 5 power 1 it is 2. 3 into 3 into 2. Answer for this question is 18. Answer for this question is 18. I think if it is not visible, let me write it down. 1 minute, sir. I'll write it here. This question, we will do it in the next slide once we understand the concept. So 360, 540, it is 180. Now see here. 180. 180 factors are 2 square into 3 square into 5. So how many factors are there? 2 power 0 to 2 power 2, 3 power 0 to 3 power 2, 5 power 0 to 5 power 1. 3 into 3 into 2. What will be the answer? 18. There are 18 factors which are common to 360 and 540. Again, I am repeating, this example is important to me. I took two single digit numbers, 6 and 9. I wrote all the factors of 6, 1, 2, 3, 6. I wrote all the factors of 9. I want the factors common to 1, 2, 6 and 9. 1 is common, 3 is common. 1 and 3. 1 and 3 are factors for which number? 3. 1 and 3 are common for which number? 3. So whenever the question is, if two numbers are given, if you want the factors common, take the HCF of two numbers. Take the HCF of two numbers. HCF of 6 and 9, it is 3. There are various ways to do HCF. Tomorrow, almost 1.5 hours, I'll spend on LCM and HCF, various ways to check it out. One of the ways is 360, it is 180 into 2. 540, it is 180 into 3. 180, it is taken out. 2 and 3, they are coprime. HCF of coprimes, it is 1. 180 factors are 2 square into 3 square into 5 power 1. 2 square into 3 square into 5 power 1. 3 into 3 into 2. There are 18 factors which are common to 360 and 540. 360 and 540. Now see here, another concept. You can also solve this problem in this way, concept. Suppose, example, I want HCF of 24, 36. HCF of 24, 36. This can be written as HCF of 12 into 2, 12 into 3. 12 into 3. 12 is common. HCF of 2 and 3. They are coprime to each other 1. 12 ones are 12. 12 ones are 12. HCF of coprimes, it is 1. This is what I did it. But you may not be able to find out the numbers in such a way that remaining factor, it is common. Another prime base method. The question may not be in natural number. The question can be in prime base method. So what you will do is, first take 24. Write down it as a power of prime bases. 2 cube into 3 power 1. 8 into 3, 24. 36. It is 2 square into 3 square. 36. It is 2 square into 3 square. HCF of 24, 36. First, 2 square, 2 cube. What is the lowest power common in 2 square, 2 cube? It is 2 square. 3 power 1, 3 square. What is the lowest power? It is common 3. 4 into 3, it is 12. Please write down. Always takes the lowest power of the. HCF can also be done by using the lowest power of the common prime basis. If the question is represented in the form of prime basis, you can use this concept. Lowest power of the common prime basis. Lowest power of the common prime basis. In case if you are not able to do like this, write every number as a power of a prime basis. 2 cube into 3 power 1. 2 square into 3 square. 2 square, 2 cube. What is the lowest? 2 square. 3 power 1, 3 square. What is the lowest? 3 power 1. 2 square, it is 4. 3 power 1, it is 12. HCF of 24 and 36. The answer is 12. Suppose if the question is like this, how many factors are common to? How many factors are common to? How many factors are common to? First question. N1 equivalent to 2 cube into 3 power 4 into 5 square. N2 equivalent to 2 square into 3 power 6 into 5 power 4. How many factors are common to? N1 equivalent to 2 cube into 3 power 4 into 5 square. N2 equivalent to 2 square into 3 power 6 into 5 power 4. So what will be the answer? Answer is defined as the HCF of N1 and N2. HCF of N1 and N2. HCF of N1 and N2. What is N1 and N2 HCF? Lowest power of the common prime basis. Lowest power of the common prime basis. 2 square, 2 cube. Lowest power of 2 is 2 square. 2 square. 3 power 4, 3 power 6. Lowest it is 3 power 4. 5 square, 5 power 4. Lowest it is 5 square. For this, we have to determine the factors. For this, we have to determine the factors. What will be the answer? 3 into 5 into 3. 5 nines are 45. 5 nines are 45. Take the HCF of two numbers and then apply the factors, because the question is how many factors are common to. We have to list down all the factors that are common to these two numbers. Factors common to these two numbers will be HCF. Factors for these HCF, it is 0 to 23, 0 to 45, 0 to 23. The question can be N1 equivalent to 3 power 5. N2 equivalent to 2 power 7. N3 equivalent to 5 power 4. 5 power 4. Please remember, if I am taking a single prime base, that should be present in all the three numbers. Suppose answer will be factors for HCF of N1, N2, N3. Factors common. 2 power should be present in N1 and N3. 2 power some number can be present. It is not possible. Or we will write like this. Into 2 power 0. Into 5 power 0. Into 3 power 0. Into 5 power 0. Into 2 power 0. Into 3 power 0. All these I added so that it will be crystal clear to you. 2 power 0, 2 power 7, 2 power 0. What is lowest power common? 2 power 0. Into 3 power 0, 3 power 0, 3 power 5. Lowest it is 3 power 0. 5 power 0, 5 power 0, 5 power 4. Lowest it is 5 power 0. 1. 1, the only factor for 1 is 1. I hope the idea it is clear. If I write like this, then it will be very, very easy for you. In HCF, I will discuss much more complex level problems. So if I am taking 3 power 5, power of 3 should be present in other two numbers. It is not present. So 1. 2 power 7, power of 2 should be present in. Please read these definition. Lowest power of the common prime basis. Common prime basis. It should be present in all the three numbers. Answer for the second question, it is 1. Answer for the first question, it is 45. How to determine the factors common using prime base method? Prime base method says write the number as a power of prime numbers and take the lowest power of the common prime basis. Lowest power of the common prime basis. I hope the idea it is clear. Each and every slide I will discuss a particular concept. Your notes will be the extreme popular book in the next coming weeks or months. Your friends will ask for your notes, mark my words, because the kind of structure in which I take the class, that is something you will not find it in any regular textbook. I know what to be taught at what level. Next one, what is the another question that we wrote and erased it? The question goes like this. How many factors for 360? How many factors for 360 are not factors for 540? Very, very good question, sir. How many factors for 360 are not factors for 540? Suppose once we understand this question, one more example we will do it. How many factors for 100 are not factors for? How many factors for 100 are not factors for 120? Two examples based upon this concept. How many factors for 360 are not factors for 540? How many factors for 100 are not factors for 120? Now, if you read the question, there is a number 360, we have to determine the factors. There is another number 540, we have to determine the factors. From first one, we have to determine the factors which are common to 360 and 540. Factors for 100 are not factors for 120 because there are two natural numbers. For the first question, there are two natural numbers. So the best way to solve this question is by using Venn diagrams. By using Venn diagrams, we will get this answer very, very fast. Venn diagrams. Instead of counting it, we will do Venn diagrams. Venn diagrams. Sets are represented using circles. This is a circle which represents the factors of 360. This is another circle which represents the factors of 540. What is this shaded region? These are the factors common to. Factor common to 360 and 540. I hope it is clear. Factors common to 360 and 540. One circle represents the factors for 360. Next circle represents the factors for 540. Now read the question. What is the question? Read the question. How many factors for 360? The circle represents the total factors for 360 are not factors for 540. That means I require these red color shaded region. In the factors of 360, there are certain factors which are common to 360 and 540. We have to eliminate it, then we will get these red color shaded region. So the question can be written as, it is nothing but what is the total factors of 360, which is the entire red circle. I want only the red shaded portion. I need to subtract the green shaded portion. What is the green shaded portion? Factors common to. Factors common to 360 and 540. I hope the idea it is clear. Total factors of 360 minus factors common to 360 and 540. 360 it is 8 9s are 72, 72 5s are 360. Factors common to 360, 540 it is 180. 180 it is 36 into 5. 2 square into 3 square into 5. I hope it is clear. Just now we did it. 360, 540. 180 into 2, 180 into 3. 2 and 3 are co-prime to each other. 180. 180. So what are the factors for this number? 4 into 0 to 3, 0 to 2, 0 to 1. 4 into 3 into 2 minus, what are the factors for this number? 3 into 3 into 2. 24 minus 18. 24 minus 18. Answer for this question is 6. Answer for this question is 6. Read the question again. How many factors for 360? For me, I need to work on the factors of 360. In that factors of 360, there are certain factors which are common to 360 and 540. Factors which are common to 360 and 540 are in the green shaded portion, which is 180. 180 factors are 2 square into 3 square into 5 power 1. How many factors will be there for this number? 3 into 3 into 2. 3 into 3 into 2 will be 18. Out of 24 factors, there are 18 factors which are common to both 360 and 540. That I need to eliminate it. That I need to eliminate it. I hope the idea it is clear. Please put a star mark on each and every question. We will not leave any single concept from factors. Whatever that is taught in the class, learn it and you can refer any book of your choice. You will be able to solve almost all models from factors to multiples. From factors to multiples. I hope the idea it is clear. Second question, we will use it with red color. How many factors for 100? This circle represents the factors for 100 are not factors for 120. There is another circle which represents the factors for 120. In this one, I require this portion. I require this portion subtracted from the blue shaded portion. Same concept. Subtracted from the blue shaded portion. So what will be the answer? Answer is factors for 100 minus factors common to 100 and 120. Factors common to 100 and 120. 100, 120. 25s are 100, 26 are 120. 5 and 6 are co-prime. So the answer is factors for 100 minus factors for 20. Factors for 100 minus factors for 20. Factors for 100. 100 it is 2 square into 5 square. 2 square into 5 square. 3 into 3. It is 9. Factors for 20. 20 it is 2 square into 5 power 1. 3 into 2, 6. So total 9, 3 into 2, 6. 9 minus 6, it is 3. 9 minus 6, it is 3. I hope these two examples are quite clear to you. In the previous question, how many factors are common to both the numbers? We did it. Now, how many factors for 360 are not factors for 540? I hope the method is clear. Best way to solve is by using Venn diagrams. Two questions based upon this model. Next one. Next one. N equivalent to 360. 360 it is 2 cube into 3 square into 5 power 1. 2 cube into 3 square into 5 power 1. Find the total number of total number of, lot of questions we'll solve. Find the total number of factors. Find the total number of even factors. Find the total number of odd factors. In factors, there are even numbers, there are odd numbers, even factors and odd factors. Factors which are multiples of 12. Factors which are multiples of 12. Which are multiples of 12. E. Factors which are not multiples of 12. Factors which are not multiples of 12. 5 problems, we will solve it one by one. Suppose if you take a number, the number will have a lot of factors. In that factors, there are some factors which are even numbers. There are some factors which are odd numbers. These odd factors. Odd factors. Odd factors. Listen carefully, sir. Odd factors. Factors, even factors, odd factors. Factors which are multiples of 12 and factors which are not multiples of 12. One by one we will go, sir. Listen carefully. Factors. Factors is 0 to 3. 4 cases. 0 to 2. 3 cases. 0 to 1. 2 cases. 4 into 3 into 2. Total 24 factors are there. Find n equivalent to 360. 2 cube into 3 square into 5 power 1. Factors 0 to 3, 4, 0 to 2, 3, 0 to 1, 2. Even factors. When I say even factors, simple language, it means factors which are multiples of 2. Factors which are multiples of 2. Listen carefully, sir. Factors which are multiples of 2. Any number multiplied by 2, it becomes an even number. I want the factors which are multiples of 2. I want the factors which are multiples of 2. Any multiple of 2 will be of the form 2k. Yes or no? Any multiple of 2 will be of the form 2k. 2 into. What will be the remaining number? 2 square, 3 square. And 5 power 1. Only 1 power of 2 I took it outside. Why 1 power of 2 I took it outside? Any number which is, any factor which is an even number, that means it should be a multiple of 2. So these are all the numbers. These are all the numbers which are getting multiplied by 2. By getting multiplied by 2, they automatically become an even number. How many factors are there for this number? 3 into 0 to 2, 3, 0 to 2, 3, 0 to 1, 2. 3 into 3 into 2. Answer is 18. Again I am repeating. Even factors. Even factors means factors which are even numbers. Even number means numbers which are multiples of 2. If I multiply it by 2, 2 cube, 1, 2, it is out. Remaining 2 square. 3 square and 5 power 1. 0 to 2, 3. 0 to 2, 3. 0 to 1, 2. 3 into 3 into 2. Total how many I got? 18 factors. Out of 24 factors, there are 18 factors which are even numbers. Out of 24 factors, there are 18 factors which are even numbers. Odd factors. Odd factors. This can be done in 2 ways. Method number 1 and method number 2. Method number 1. Method 1 is total factors minus total number of even factors. Total factors minus total number of even factors. I will get odd number of factors. I will get odd number of factors. So total factors, how many are there? 24. Even factors, how many are there? 18. 24 minus 18. What will be the answer? 6. If I want the odd factors, total factors minus total number of even factors, I will get odd factors. Method 2. Odd factors means factors which are odd numbers. What do you mean by an odd number? Odd number is a number which is not divisible by 2, which are not multiples of 2. which are not multiples of 2. Listen carefully, sir. Which are not multiples of 2. N equivalent to 2 power 3 into 3 square into 5 power 1, which are not multiples of 2. Remove all the powers of 2. Even if you keep 2 power 0, 1 into any number, it does not change. So I am removing all the powers of 2. If I remove all the powers of 2, that means the number is never divisible by 2. If it is never divisible by 2, remaining number are the factors which are odd numbers. 0, 2, 2, 3, 0, 2, 1, 2. What will be the answer? 6. Factors which are not multiples of 2. Any factor which are not multiples of 2 means remove all the powers of 2. 2 power 3 is taken out. Even if you keep 2 power 0, 1, answer will not be changing. So 0 to 2, 3 cases, 0 to 1, 2 cases. Even factors which are multiples of 2. Odd factors which are not multiples of 2. Factors which are not multiples of 2. I hope the idea it is clear. Now, from here onwards, you can solve the question very, very easily. Now see here. Factors which are multiples of 12. Any multiple of 12 is of the form 12k. Any multiple of 12, it is of the form 12k. 12 is 2 square into 3. Remaining will be 2 cube, 2 square is taken out. Remaining is 2 power 1. 3 power 1 is taken out. Remaining is 3 power 1. Into 5 power 1. These are the numbers which are getting multiplied by 12. So how many factors are there for this number? 2 into 2 into 2. 2 into 2 into 2. Totally, how many multiples of 12 are there? 8 factors. I hope it is clear. If it is a multiple of 6, write down 6k. If it is a multiple of 12, write down 12k. Factors which are not multiples of 12, which can be written as total factors minus factors which are multiples of 12. Total factors will be 24. Factors which are multiples of 12 will be 8. 24 minus 8, it is 16. 24 minus 8, it is 16. I hope the idea it is clear. Factors which are multiples of 12, factors which are not multiples of 12. How to find out the factors? How to find out the even factors? How to find out the odd factors? Odd factors are the factors which are not divisible by 2. Eliminate all the powers of 2. Are total factors minus total number of even factors. Total factors minus total number of even factors. 5 examples clear, right? Next one, please write down. N equivalent to 360. 360, write down it as a power of prime basis 2 cube into 3 square into 5 power 1. How many factors? How many factors are of the form? How many factors are of the form 3k multiples of 3? 3k plus 1 and 3k plus 2. Another model. How many factors are of the form 3k, 3k plus 1 and 3k plus 2? Listen carefully, sir. N is 360. 2 cube into 3 square into 5 power 1. How many factors are of the form 3k, 3k plus 1, 3k plus 2? How many factors are of the form which are multiples of 3? 3 is taken out. Bracket it is 2 cube. Next it is 3 power 1. Next it is 5 power 1. 2 cube into 3 square into 5 power 1. I hope it is clear. These are the numbers which are getting multiplied by 3. Therefore, it becomes factors which are multiples of 3. How many factors are there? 0 to 3, 4. 0 to 1, 2. 0 to 1, 2. 4 into 2 into 2. Total 16 factors are there which are multiples of 3. I hope it is clear. When you divide a number by 3, remainder 0, remainder 1, remainder 2. 3 possible remainders you will get. That means sum of these 3, sum of the factors for 3k, 3k plus 1, 3k plus 2 should be equivalent to total factors 0 to 3, 0 to 2, 0 to 1. 4 into 3 into 2, it is 24. Total sum of these three factors should be equivalent to 24. How many factors are of the form 3k, 3k plus 1, 3k plus 2? Any number which is divisible by 3, it is 3 into 2 cube into 3 power 1. Already 1 power of 3 it is there. Into 5 power 1. 4 into 2 into 2. 16 factors we got. Listen carefully for this. Listen carefully. B. 3k plus 1. What do you mean by 3k plus 1? It is not divisible by 3. Because when it is divided by 3, it gives a remainder 1. 3k plus 1 means the number is not divisible by 3. Number is not divisible by 3. 2 cube into 3 square into 5 power 1. Listen carefully, sir. 2 cube into 3 square into 5 power 1 into 5 power 1. Now see here. It is not divisible by 3. Because it is not divisible by 3, remove 3 square here. Remove 3 square here. Similarly, it is of the form 3k plus 2. 3k plus 2. 3k plus 2 means when it is divided by 3, it gives a remainder 2. That means it is not perfectly divisible by 3. 3 square eliminated. 3 square eliminated. This is 2 power 0, 2 power 1, 2 square and 2 cube. 5 power 0, 5 power 1. 3 square, all the powers are eliminated. All the powers are eliminated. What is that we require? 3k plus 1. Divide every number by 3. 2 by 1 divided by 3, 1. 2 divided by 3, 3 ones are 3. Negative remainder minus 1. 4 divided by 3, it is 1. 8 divided by 3, 3 threes are 9. Minus 1. I divided every number by 3 because it is of the form 3k plus 1. 5 power 0, 1 divided by 3, 1. 5 divided by 3, 3 twos are 6. Minus 1. What I should get? Plus 1. Wherever plus 1 combinations are there, that will be possible. These 1 into 1, 1 out, right? Next one, minus 1 into minus 1, plus 1, another case. Are you all with me? 1 should be multiplied by 1 to get 1. Minus 1 should be multiplied by minus 1. 1 into 1, 1 over minus 1 into minus 1. Again it is plus 1. Here, minus 1 into plus 1. I hope it is clear. So, totally 4 cases we got. What are that 4 cases? I am writing it here. 1 into 1. 2 power 0 into 5 power 0. Next one, minus 1 into minus 1. 2 power 1 into 5 power 1. Next one, 1 into 1. 2 square into 5 power 0. Minus 1 into minus 1. 2 cube into 5 power 1. Check all the cases. 1 into 1, 1. 1. 3 zeros are 0, remainder 1. 2 into 5, 10. 10 divided by 3, remainder 1. 4 into 1, 4. 4 divided by 3, remainder 1. 8 5s are 40. 3 13s are 39, remainder 1. So totally, how many cases I got? 4. I hope it is clear. Again, I am explaining. If needed, I will take one more question and I will solve it. Now see here. 2 cube into 3 square into 5 power 1. It is not divisible by 3. So power of 3 are out. Because it is 3k plus 1, whatever the remaining powers, take everything when divided by 3. Simple, it will be 1 into 1, 1, minus 1 into minus 1, 1. 1 divided by 3, 1. 2 divided by 3, minus 1. 4 divided by 3, 1. 8 divided by 3, minus 1. 1 with minus 1. 1 with 1, 1. Minus 1 with minus 1, 1. 1 with 1, minus 1 with minus 1. Totally 4 cases I will get it. I hope the idea it is clear. Similarly, here also we will do it. 2 power 0, 2 power 1, 2 square, 2 cube. 5 power 0, 5 power 1. I need to get 3k plus 2. I need to get 3k plus 2. 2 divided by 3, 1. 2 divided by 3, minus 1. 2 power 0 divided by 3, 1. 4 divided by 3, 1. 8 divided by 3, minus 1. It is 1. 5 divided by 3, minus 1. What I should get? 2 remainder. 2 remainder, it is also of the form 2 divided by 3 minus 1. Either plus 2 is the positive remainder or minus 1 is the negative remainder. So 1 with minus 1, one case. Minus 1 with 1 case. 1 with minus 1, one case. Minus 1 with 1 case. 4 cases. What are that 4 cases? We will write down here. 2 power 0 into 5 power 1. 1 into minus 1. 2 power 1 into 5 power 0. Another case. 2 square into 5 power 1. Next case. 2 cube into 5 power 0. 2 cube into 5 power 0. I hope the idea it is clear. 1 into 5, 5. 5 is 3k plus 2. 3k plus 2. 5 into how much? What is this case? 2 square into 5. 4 5s are 20. 3 6 are 18 plus 2. 8 into 1, 8. 3 2s are 6 plus 2. When it is divided by 3k, when it gives a remainder 1 and when it gives a remainder minus 1. Seems like a little challenging, but once you understand, this question is very, very easy. I hope the idea it is clear. 3k plus 1, 3k plus 2. I will do one more example so that it will be crystal clear to you. I hope the idea it is clear. 16 plus 4 plus 4, 24, which is equivalent to total factors. Now see here. Same model, I will do one more. N is 420. What are 420 factors? 420 factors are 4 into 105, 3 into 35, 5 into 7. 4 is 2 square. 2 square into 3 into 5 into 7. 2 square into 3 into 5 into 7. You can easily solve it. How many factors? How many factors are of the form? How many factors are of the form 4k? 4k plus 1, 4k plus 2, 4k plus 3. Another example, but this time it is divided by 4. It could be anything. Divided by 4, divided by 3, divided by 6. 4k, 4k plus 1, 4k plus 2 and 4k plus 3. Listen carefully, sir. 4k plus 1, 4k plus 2 or 4k plus 3. One by one we will go. 4k, when it is divided by 4k, 4 is 2 square into. Remaining it is 3 into 5 into 7. 3 into 5 into 7. I hope the idea it is clear. So these are the numbers which are multiplied by 4, which will become 4k. How many factors are there? 0 to 1, 0 to 1, 0 to 1. 2 into 2 into 2. 2 into 2 into 2, 8. There are 8 factors which are multiples of 4. There are 8 factors which are multiples of 4. 4k plus 1. Now see here. N equivalent to 2 square into 3 into 5 into 7. 4k plus 1. That means when it is divided by 4, it gives a remainder 1. When it is divided by 4, it gives a remainder 1. That means it is not divisible by 4. Out. Are you all with me? 3 into 5 into 7. 3 power 0, 3 power 1. 5 power 0, 5 power 1. 7 power 0, 7 power 1. Because it is divided by 4, divide every number by 4. 1 divided by 4. 4 divided by 3. Minus 1. 1 divided by 4. 1. 5 power 1. 5 divided by 4. 1. 7 power 0. 1. 7 divided by 4. 4 2s are 8. minus 1. I hope it is clear. Now, how many cases will be there? It gives 4k plus 1. 1 into 1 into 1. 1 into 1 into 1. 3 power 0 into 5 power 0 into 7 power 0. 1 into 1 into 1. It is 1. Next case, 1 into 1 into 1. It is also 1. So 3 power 0 into 5 power 1 into 7 power 0. I hope you are understanding. I need to get a reminder 1. 1, 1, 1. 1 not possible. 1, 1, 1. Minus 1. Minus 1 into minus 1 into 1 into minus 1. Minus 1 into 1 into minus 1. 3 power 1 into 4 power 0 into 7 power 1. Are you with me? 3 power 1 into 5 power 1 into 7 power 1. 3 power 1 into 5 power 1 into 7 power 1. These 1, 1, 1, 1. Next it is 5. 5 divided by 4, 1. 5 3s are 15. 15 7s are 105. 4 26 are 104. Remainder 1. 3 7s are 21. 4 5s are 20. Remainder 1. Totally how many cases I got? 4 cases here I got. 4 cases here I got. 4k plus 2. 4k plus 2 is 2 into 2k plus 1. 2 into 2k plus 1. Power of 2, it is fixed. 2k plus 1, it is an odd number. 2k plus 1, it is an odd number. Keep the power of 2 as 1 and the remaining, it is an odd number. How many odd factors are there for this number? How many odd factors are there? It is 2 into 2 into 2. 2 into 2 into 2. 4 2s are 8. 4 2s are 8. I hope it is clear. Totally how many factors are there for this number? 3 into 2 into 2 into 2. 2 2s are 4. 4 2s are 8. 8 3s are 24. Out of these 24, 4 cases I got here. 8 cases I got here. 4 plus 8 is 12. Here I will get another 12 cases. Sorry. 8 plus 4, 12. 12 plus 8, 20. Here 4 cases I will get. Here 4 cases I will get. 4k, 4k plus 1, 4k plus 2, 4k plus 3. Even if you want 4k plus 2, 4k plus 2, what you will do is 4k plus 2 is 2 into 2k plus 1. Power of 2, it is fixed. Suppose in case if you want me to solve like this, n equivalent to 2 square into 3 into 5 into 7. I want 2 as a 2 power 1 only. Remaining it will be 3 power 0, 3 power 1, 5 power 0, 5 power 1, 7 power 0, 7 power 1, 2 into 2 into 2. Total 8 cases. Factors when it is divided by 3, remainder 0, remainder 1, remainder 2. When it is divided by 4, remainder 0, remainder 1, remainder 2, remainder 3. 4k I got 8. 4k plus 1 I got 8. 8 plus 8, 16. 16. 16. 16 plus 4, 20. 8 plus 8 plus 4, 20. Out of 24, 20 factors are out. So the answer is remaining 4. I hope the idea it is clear. Is the idea clear? I hope it is clear. In the examination, in your examination, there is a question like this. How many factors for how many? The question is like this. How many factors for? How many factors for 240? This is an exam model question, sir. How many factors for 240 are of the form 4n plus 2? 4n plus 2. Just now we discussed. Only to discuss this one, I discussed the previous question. What if it is 4n, 4n plus 1, 4n plus 3? How many factors for 240 are of the form 4n plus 2? 4n plus 2 is 2 into 2n plus 1. 2n plus 1, it is an odd number. So power of 2, we have to fix it. 240, it is 2 into 120. 2 into 120 it is 2 square into 3 into 5. 2 square into 3 into 5. Now see here, 2 square into 3 into 5. 2 into any number. This, for these odd factors means it cannot take power of 2. 3 power 0, 3 power 1. 5 power 0, 5 power 1. 2 into 2, 4 cases. 2 into 2, 4 cases. I hope it is clear. So 2 into 2n plus 1. For this number, I want odd factors. Odd factors are the factors which are never divisible by 2. 2 square it is out. 3 power 1 into 5 power 1. 3 power 0, 3 power 1. 5 power 0, 5 power 1. So 2 into 2, total 4 cases. Last 10 minutes, extremely important. How many factors when divided by 3, either perfectly divisible 3k or 3k plus 1 or 3k plus 2. Idea clear? I hope all these. This class, kindly revise it in the next 24 hours. Next concept. N equivalent to 360. 2 cube into 3 square into 5 power 1. 2 cube into 3 square into 5 power 1. Now see here. Listen carefully, sir. How many? Question is, how many factors for n are? First question. Perfect squares. How many factors for n are perfect square? Non-perfect squares, another model. How many factors for n are perfect squares, non-perfect squares, perfect cubes, and non-perfect cubes. 4 questions we will discuss. Another important model. Based upon this model, we can create another 3-4 good quality questions, sir. N equivalent to 360. 360 is 8 9s are 72, 72 5s are 360. How many factors for n are perfect squares, non-perfect squares, perfect cubes, and non-perfect cubes? First, we will write the concept here. First concept. A perfect square. What is the definition of a perfect square? Power will be an even number. And 0. First key point. Definition of a perfect square is number multiplied by itself. If I multiply a number by itself, I will get a perfect square. Power 0, it is also a perfect square. Second key point. A perfect square into perfect square. A perfect square into a perfect square will always give another perfect square. 4 into 9 is 36. 36 is a perfect square. 2 square into 3 square. 144. 144 is 16 into 9. Third key point. I require a perfect cube. Perfect cube means power should be a multiple of 3 and 0. One is a perfect square, one is a perfect cube. Fourth key point. A perfect cube into perfect cube. A perfect cube into perfect cube is always a perfect cube. 2 cube into 3 cube, 8 into 27, 216, which is 6 cube. A perfect square will have power and even number. Even number is a number which is a multiple of 2. Even number is a number which is a multiple of 2. If I want the factors which are perfect squares, that factor power should be a multiple of 2. Power should be, if it is a perfect cube, power should be a multiple of 3 and 0. All these 4 key points which we will do it. Now, first one. How many factors for n are perfect square? First key point says, for a factor to be a perfect square, power should be an even number and 0. So 2 power 0, 3 power can be 0. 2 power 0, 3 power 0 and 5 power 0. Power can be an even number. 2 square, 3 square, that's all. There is no 5 power 2 here. So 2 square into 3 square. 2 perfect squares product is also a perfect square. How many combinations here? 2. 2 into. How many combinations here? 2. 5 power 0, there is 1. 2 into 2 into 1. Total, what will be the answer? 4. A perfect square power should be an even number and 0. So I started with 0. 2 power 0, 3 power 0, 5 power 1. Next even power of 2 is 2 square. Even power of 3 is 3 square. So 2 into 2 into 1. 4 cases. Factors which are non-perfect squares. Factors which are non-perfect square is total factors. Total factors minus factors which are perfect squares. Minus factors which are perfect squares. Am I right? So total factors will be 4 into 3 into 2 minus it is 4. So total 24 minus 4. Factors which are non-perfect squares are 20. Factors which are non-perfect squares are 20. I hope the idea it is clear. It's the simple definition of a perfect square. Once you understand the definition of a perfect square, then the process will become very easy. Next one. Perfect cube. Perfect cube will have power a multiple of 3 or 0. So 2 power 0. 3 power 0, 5 power 0. Perfect cube, it is 2 cube. Next, there is nothing beyond 3 power 2, so eliminated. So 2 into 1 into 1, which is 2. Which is 2. 2 power 0 into 3 power 0 into 5 power 0. 1 is a perfect cube. 8 into 1 into 1. 8 it is a perfect cube. A perfect square, power should be an even number including 0. Perfect cube, power should be a multiple of 3. Non-perfect cube. Non-perfect cube means total factors minus factors which are perfect cubes. Total factors which is 24 minus 2. Answer is 22. Answer is 22. I hope this slide talks about factors which are perfect squares, factors which are non-perfect squares, factors which are perfect cubes, and factors which are non-perfect cubes. Instead of writing all these, what we'll do is, we will understand a logic. See here. N equivalent to 2 power 7 into 3 power 8 into 5 cube. N equivalent to 2 power 7 into 3 power 8 into 5 cube. We want, I took a little larger number. We want the factors. We want the factors for n. We want the factors for n, which are, we will optimize the number of steps. First one, perfect squares. We want the factors for n, which are perfect squares. Next it is perfect cubes. Next it is perfect cubes. Listen carefully, sir. Method 1. What we will do? A perfect square means power can be 0. 2 power 0, 3 power 0, 5 power 0. And power has to be an even number. 2 square, 2 power 4, 2 power 6. 3 square, 3 power 4, 3 power 6, 3 power 8. 5 square. Am I right? We will write like this. So totally how many combinations I got? 4 combinations for power of 2. 1, 2, 3, 4, 5. 5 combinations for power of 3. 2 combinations for power of 2. 22s are 40. 22s are 40. Instead of writing like this, what we will do is, we will optimize it. What do you mean by a perfect square? A perfect square means power should be an even number, including 0. Even number is always divisible by 2. Divide the power by 2. Divide the power by 2. Divide the power by 2 and add 1. Why are we adding 1? We are adding 1 because 2 power 0, 3 power 0, 5 power 0, all these are equivalent to 1. 1 is a perfect square, 1 cube. Why we are dividing the power by 2? A perfect square, power should be an even number. Even number is divisible by 2. Even number is divisible by 2. Now see here. Directly divide n equivalent to 2 power 7 into 3 power 8 into 5 cube. 7 by 2, 3.5. Ignore decimal. Please write down. Ignore the decimals. Ignore the decimals. Ignore the decimal value. 7 by 2, 3.5. 3 plus 1. What are these 3? 2 square, 2 power 4, 2 power 6. What is plus 1? 2 power 0, 1 is a perfect square. Similarly, 8 by 2, 4 plus 1. If you write and get an integer, write it as it is. If you get a decimal, ignore the decimal. Why it is 4 plus 1? 4 cases are these 4 cases. 1 case is 3 power 0. 3 by 2, 1.5. Ignore decimal. 1 plus 1. What is that one case? 5 square. Plus 1, 5 power 0. So answer is 4 into 5 into 2. If the number powers are very, very large, what you can do is divide the power by 2 and add 1. Why are we dividing the power by 2? Because the power should be an even number. Because we require the factors which are perfect squares. We require the factors which are perfect squares. Similarly, next question, perfect cubes. Perfect cubes means power should be a multiple of 3. 2 power 0, 2 power 3, 2 power 6. 3 power 0, 3 power 3, 3 power 6. 5 power 0, 5 power 3. Total how many cases we got? 3 cases here. Again 3 cases here. 2 cases here. 3 into 3 into 2. Total 18 cases. Same approach we will do it here. Same approach. Perfect square, power is an even number. It should be divisible by 2. If it is a perfect cube, divide the power by 3. Divide the power by 3 and add 1. Why? Because perfect cube means power should be divisible by 3. So what is the question? Question is n equivalent to 2 power 7 into 3 power 8 into 5 power 3. 7 by 3, 2 point something. Ignore the decimal. Add 1 because 2 power 0 is a factor. 8 by 3, 2 point something. 2 plus 1. 3 by 3, 1 plus 1. 3 into 3 into 2, which is 18. 18 factors are there which are perfect cube for these number. Perfect cube means divide the power by 3. Perfect fourth power means divide the power by 4 and add 1. Perfect square means divide the power by 2 and add 1. Divide the power by 2 and add 1. Perfect square and perfect cube. Perfect square and perfect cube. I hope the idea it is clear. Where it will be useful? It will be useful if the value it is very high. N equivalent to 2 power 17 into 3 power 13 into 5 power 9. Factors which are perfect squares. Factors which are perfect squares. Second one, factors which are perfect cubes. Directly you can get the answer and save a lot of seconds time by writing. Square means divide the power by 2. 17 by 2, 8.5. Ignore the decimal. 13 by 2, 6.5. 9 by 2, 4 plus 1. It is 9 into 7 into 5. 9 into 7 into 5. Factors which are perfect cubes. 17 by 3, 5 plus 1. 13 by 3, 4 plus 1. 9 by 3, 3 plus 1. So 6 into 5 into 4, which is 120 here. These 315 here. 315. Factors which are perfect squares, divide the power by 2 and add 1. Divide the power by 2. Suppose if the question is factors which are perfect squares, factors which are perfect squares but not perfect cubes. Another question, factors which are perfect squares which are but not perfect cubes. Already we did this question by using Venn diagram. These the factors which are perfect squares, factors which are perfect cubes, factors which are perfect squares and factors which are perfect cubes. What do we require? But not perfect cubes. This region we require. This region we require. So what is this region? This region is total factors for perfect squares minus factors common to perfect squares and perfect cubes. Factors which are perfect squares. So these equivalent to. What will be the answer for this question? Each and every question right after the class, practice it, sir. Factors which are perfect squares. Factors which are perfect squares minus factors common to perfect square and perfect cube. Perfect square and perfect cube. Factors common. Please write down. So what it will be? Factors which are perfect squares will be 315 minus factors which are common to square and cube will be 6th power. 6th power, how many we got? N equivalent to 2 power 17 into 3 power 13 into 5 power 9. 2 power 0, 2 power 6, 3 power 2 power 12. 3 power 0, 3 power 6, 3 power 12. 5 power 0, 5 power 6. Minus 3 into 3 into 2. 315 minus 18. Whatever the answer, 297 will be the answer. Factors which are perfect square but not perfect cubes. There are numbers which are common to both square and a cube. Common to both square and a cube is a 6th power. 6th power means divide the power by 3 and add 1. 2 power 0, 2 power 6, 2 power 12. 3 power 0, 3 power 6, 3 power 12. 5 power 0, 5 power 6. 3 into 3 into 2. 3 into 3 into 2 is 18. 315 minus 18. I hope the idea it is clear. From this, a very, very important concept can be derived. We will discuss that concept and we'll solve problems based upon this concept. Factors which are perfect squares, factors which are non-perfect squares, factors which are perfect cubes, and factors which are perfect squares but not perfect cubes. Note, please write down. Note. Very, very important, sir. A perfect square always has odd number of factors. A perfect square always has odd number of factors. If a number is a perfect square, it always has odd number of factors. If a number is a perfect square, it always has odd number of factors. Proof. I will do it with a proof with example and I'll do it with proof with concept. Suppose n equivalent to 36. 36 is 4 into 9. 4 written as a power of prime number, 2 square. 9 written as a power of prime number, 3 square. 2 square into 3 square. So totally, how many are there? 2 power 0, 2 power 1, 2 power 2. 3 power 0, 3 power 1, 3 power 2. 3 power 2. If I list all the factors, total here I got 9 factors. Why it will be 9? If the perfect square power will be an even number. 0 to even, I will get odd. 0 to odd, even, I will get odd. A perfect square always has got power an even number. When you are doing number of factors, you will do 0 to even, 0 to even, odd, 0 to even, odd, odd into odd, I will get odd. I hope the idea it is clear. In case if you want the factors, 1, 2, 3, 4, 6, 9, 12, 18, 36, 3, 6 and 9 cases. I hope it is clear. A perfect square, always the power will be an even number. So 0 to even, I will get odd. 0 to even, I will get odd. Next one, suppose if I do with a single prime base, P1 power 2a. P1 power 2a. What will be the factors for P1 power 2a? P1 power 2a. P1 power 2a. 0 to 2a. 0 to 2a. 0 to even, it will be odd. So with a single prime base, how many factors will be there? Odd. 0 to even, it is odd. Suppose there are two prime bases, P1 power 2a into P2 power 2b. P1 power 2a into P2 power 2b. Here I will get 0 to 2a, 0 to even, odd. 0 to even, it will be odd. Odd into odd, it will be even. Odd into odd, it will be even. I hope the idea is clear. If the power is an even number, 0 to even odd, 0 to even odd. Similarly, if there are three prime bases, P1 power 2a, P2 power 2b, P3 power 2c, 0 to even odd, 0 to even odd, 0 to even odd. Odd into odd. Sorry, here it is an odd number. I did odd plus odd. Let me erase it, sir. So this will be an odd number. Odd number. Here also it will be an odd number. Odd into odd. I hope the proof is clear. Why a perfect square always has odd number of factors. Reverse is also true. Reverse is also true. If a number has got odd number of factors, if a number has got odd number of factors, then the number is definitely a perfect square. If a number is a perfect square, it has odd factors. If a number has got odd number of factors, then it is a perfect square. I hope the proof is clear. A perfect square power will be an even number. 0 to even odd, 0 to even odd, 0 to even odd, 0 to even odd, odd into odd into odd, odd. Suppose if the question is, n has, for example, 5 factors. N has 5 factors. The value of n. The value of n. If the question is 512, 625, 839, 839, and the next one is 140, 145. If a number has got 5 factors, what will be the value of n? You don't need to do anything. A number has got 5 factors. If a number has got odd number of factors, if a number has odd number of factors, if a number has odd number of factors, then it is a perfect square. If a number has odd number of factors, it is a perfect square. Perfect square never ends with 2. A perfect square is always of the form 4k or 4k plus 1. Any perfect square ending with 5, tens place is 2. Tens place it is 2. So answer for this question is 625. Very, very important concept. A perfect square power will be an even number. When you are determining the number of factors, power is an even number. 0 to even number, it will be odd. 0 to even number, it will be odd. Very, very important concept, sir. A perfect square always has odd number of factors. First concept. Second one, listen carefully, sir. Second concept. Key point 2. This based upon These two key points, let us solve a problem. Key point 2. Suppose if I take 144, 144 it is 12 square. 12 can be written as 2 square into 3 whole square, which is 2 power 4 into 3 square. Into 3 square. Are you all with me? How many factors are there for this number? 0 to 4, 5. 0 to 2, 3. 5 into 3. Total 15 factors are there. There is a reason I will list all the factors. So the factors for 144 will be 15 factors will be there. What are that? 1, 2, 3, 4, 6, 8, 9, 12, 18, 24, 36, 48, 72. 72 and 144. Listen carefully. How many are there? 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15. Listen carefully to this key point. 144, it is a perfect square. So the first thing is square root of 144, it is 12. 12 is present in this number. 12 is present. How many factors are there less than 12? 1, 2, 3, 4, 5, 6, 7. That means if n is a perfect square, n is a perfect square, n is a perfect square, root n will be a factor. I hope it is clear. Root n will be a factor. Root n will be a factor. Less than root n, if there are k factors. Less than root n, if there are k factors. 1, 2, 3, 4, 6, 8, 9. Total 7 factors are there. Greater than root n. Please count it. 1, 2, 3, 4, 5. Right? 18, 24. Totally 1, 2, 3, 4, 5, 6, 7. If it is 7, here also it should be 7. That means we missed out one number. What is that number? Let us see. 18 we have taken. We have taken 9. We have taken 18, 24, 36, 48, 72. 1, 2, 3, 4, 5, 6. One number we have missed it out. 16 we missed it out. So because of the understanding of the concept, we will get it very clearly. So let me write down here. 16 nines are 144. Even if I miss out any case, that can be obtained because of the conceptual clarity. I have got 12, 16, 18, 24, 36, 48, 72, and 144. Listen carefully. 12 is root n. Total, how many factors are there? 3, 6, 7. Right side also 3, 6, 7. There are 7 factors to the greater than root n. There are 7 factors to the less than root n. See here, sir. 144. Then I will write that point. 2 power 4 into 3 square. Factors for 144. Factors for 144. 5 into 3, 15. 5 into 3, 15. There is one case, root n into root n. Yes or no? Root 144 into root 144. 14 cases. 7 factors less than root n. There are 7 factors greater than root n. Please write down this point. If 15 factors are there for 144, one factor will be root n. One factor, I will write down. One factor will be root n. 7 factors will be less than root n and 7 factors will be greater than root n. Because the number is a perfect square, 36 is there. 6 will be one factor. Less than 6, greater than 6. I hope the idea it is clear. Less than 6 and greater than 6. Suppose if the question is, if n is a perfect square, if n is a perfect square, less than root n, 30 factors are there. 30 factors are there. How many factors will be there for n? Tell me the answer. If n is a perfect square, if n is a perfect square, if less than root n, 30 factors are there. Greater than root n also, there will be 30 factors. There will be 30 factors. And one factor will be root n. So 30 plus 1. Answer will be 61. If a number is a perfect square, less than root n number of factors, greater than root n number of factors will be same. Less than root n 30, greater than root n 30. You cannot add 30 plus 30. Why? Because it is a perfect square. Perfect square always has odd number of factors. So there will be one factor which is root n. 30 plus 1 is 61. Very, very important key point, sir. A perfect square always has odd number of factors. What are that? Suppose I will write down here. If n is a perfect square, if n is a perfect square has odd number of factors. So 2k plus 1 factors. 2k plus 1. 1 will be root n. K will be less than root n. And another k will be greater than root n. I hope the idea it is clear. How 2k plus 1 has been split? One factor will be root n, less than root n, and it is greater than root n. Idea it is clear. Next 4 questions, cat level questions, one by one we will discuss. One for root n, less than root n k, greater than root n k. I hope the idea it is clear. Now if the question is, if a number has got 121 factors, 121 factors, how many factors less than or equivalent to 2n root n are there? Less than or equivalent to root n are there? First question. Number has got 121 factors. Factors less than or equivalent to root n. Factors less than or equivalent to root n. 121 factors are there. So how it will be split? One factor will be root 121 11. There will be one factor here 11. I'll erase it, write it neatly. This will be one factor will be root n. Next will be 120. 60 this side, 60 this side. What are this? These less than root n, and this is greater than root n, and this one factor is equivalent to root n. Equivalent to root n. Factors less than or equivalent to 60 plus 1, 61. Next question. How many factors greater than root n? Greater than root n will be 60. Once you understand this question, these concepts are very, very easy, sir. Only thing is that you have to know in depth the understanding of this problem. I hope the idea it is clear. I hope the idea it is clear. What if the number of factors are even? That also we will see. This clear? Next is a cat level question. Cat level question. Listen carefully, sir. Beautiful question it is. Probably the best question of the day. Cat level question. The question is, there is a natural number n. There is a natural number n which has got x factors. There is a natural number n which has got x factors. I squared these natural number. I got p factors. There is a natural number n which has got x factors. I squared these natural number. I got p factors. X plus p, the value came out to be 34. X plus p, it is equivalent to 34. What is the nature of n? What is the nature of n? What is the nature of n? First option, perfect square. Second option, even number. Third option, prime number. Fourth option, odd number. Beautiful question, sir. Students who got a very good understanding of fundamentals can solve this question very, very fast. There is first read the question. There is a natural number n. N has got x factors. Square that number. I got p factors. X plus p is equivalent to 34. What is the nature of n? The first thing, 34, it is an even number. 34, it is an even number. 34, it is an even number. Next, p factors. N square, it is a perfect square. N square, it is a perfect square. Are you all with me? N square, it is a perfect square. A perfect square will always have odd number of factors. A perfect square will always have odd number of factors. Idea clear? Something plus odd is even. That means x should also have odd number of factors. Why? Because odd plus odd can only give you even. Odd plus odd can only give you even. X has got odd number of factors. If a number has got odd number of factors, then that number is a perfect square. Then that number, it is a perfect square. What is the option? Perfect square. Beautiful question, sir. X plus p is equivalent to 34. 34, it is an even number. I am squaring this number. If I square this number, I will always get odd number of factors. P is an odd number of factors. P will be an odd number of factors. Something plus odd, it is an even number. Something plus odd, it is an even number. That something should be an odd number. That something should be an odd number. Odd plus odd can only give me odd. X has got a value which is odd. Odd number of factors. Which number will have odd number of factors? That number will be a perfect square. A beautiful cat replica question which is checking out your concepts. Can you use that concept of every perfect square has odd number of factors? Each and every question, whatever I am discussing in class, kindly make your own notes, solve the question again and again. Your fear of looking at any new model in number system, it will vanish after each progression of each and every class. Like that number system, arithmetic, algebra, geometry, modern maths, I will take you to a level where you will be supremely confident in the topic that we are going to discuss. The only thing is, in case if I think that I need to discuss some more problems, I might conduct some little extra sessions. Bear with me. Do understand that even I have a family to spend, I have to run a company. When I'm taking an extra class, that is for your benefit, not for me, because I just don't want to leave any important concept. I am not the teacher who teaches on surface. If I take a topic, I will discuss in detail. I'm sure most of the enrolled students, by this time you should have understood how I take the class. Comprehensive, streamlined curriculum. I hope the idea it is clear. Next one. Next, another few questions. Let us solve. How many natural numbers? How many natural numbers less than 65? How many natural numbers less than 65 has odd number of factors? How many natural numbers less than 65 has odd number of factors? Has odd number of factors. Very, very good question, sir. How many natural numbers less than 65 has odd number of factors? Now tell me, which natural numbers will have odd number of factors? Any natural number which has got odd number of factors. Any natural number which has got odd number of factors. Odd number of factors. odd number of factors. That number is called a perfect square. That number is called a perfect square. That number is called a perfect square. How many perfect squares are there? 1 square, 2 square, 3 square, and so on up to 8 square. How many natural numbers less than 65 has odd number of factors? Answer will be 8. All the perfect squares less than 65 has odd number of factors. I hope it is clear. One more question. One more question. Now see here. Out of first 100 even natural numbers, out of first 100 even natural numbers, out of first 100 even natural numbers, how many numbers? Another beautiful question, sir. How many numbers has even number of factors? Has even number of factors? Has even number of factors. Read this question once. Out of first 100 even natural numbers, out of first 100 even natural numbers first 100 are 2 ones are, 2 twos are, 2 threes are, 2 fours are, 2 hundreds are, 200. This is the domain of the question. Out of first 100 even natural numbers, how many numbers has the even number of factors? So the numbers which has even number of factors, numbers which has even number of factors, numbers which has even number of factors, it is nothing but total numbers minus numbers, total numbers minus numbers which has got odd number of factors, minus numbers which has got odd number of factors. Total how many numbers are there? 100 numbers are there. Minus numbers which has got odd number of factors. Numbers which has got odd number of factors are called as perfect squares. Please do not take 1 square, 3 square. Question domain is on even number. Question domain is on even number. So it will be 2 square. 1 square you cannot take, 4 square, 6 square, 8 square, 10 square, 12 square, 14 square. You cannot take 16 square. 16 square is 256. 2 square, 4 square, 6 square, 8 square, 10 square, 12 square, and 14 square. Totally, how many are there? 1, 2, 3, 4, 5, 6, 7. 100 minus 7. So answer for this question will be 93. Answer for this question will be 93. Out of first 100 even numbers, first 100 even numbers are 2, 4, 6, 8, and so on up to 200. I require the numbers which has even number of factors. So numbers which has got even number of factors are defined as total numbers minus numbers which has got odd number of factors. Numbers which has odd number of factors are called perfect squares. 2 square, 4 square, 6 square, 8 square, 10 square, 12 square, 14 square. Upper limit is 200. So stop at 14 square. Don't take any odd numbers because the question is on even numbers. Question is on even numbers. 100 minus 7 is 93. I hope this question is clear. Next one. Suppose if the question is 2 power 7 into 3 power 8 into 5 cube. How many factors for n? How many factors for n are divisible by 50? Are divisible by 50 but not by 100. Divisible by 50 but not by 100. but not by 100. Divisible by 12. Divisible by 12, but not by 18. Divisible by 12, but not by 18. Another model, sir. N equivalent to 2 power 7 into 3 power 8 into 5 power 3. How many factors for n are divisible by 50, but not by 100? Divisible by 12, but not by 18. Most of the students, because we discussed this model of but not by, they will solve this traditional method. This is the circle which are divisible by 50. Take the factors which are multiples of 50. These are the factors which are multiples of 100. From this, what do we require? Divisible by 50. This portion we require. Already we did this method from the factors which are common. This is the traditional method which we will do. I will write down this method which you will do, then we will optimize it. So factors which are multiples of k per n minus factors which are common to 50, 100 per n. This is the method which you will use. Am I right? You don't need to use this method. There is a better optimized version that we will see it. Method number 2. Method number 2. Now listen carefully. 50 is 5 square into 2. 100 it is 5 square into 2 square. 25 into 4 it is 100. 25 into 2 it is 50. I need it by 50 but not by 100. What is common in both of them? 5 square. 5 square. Now see here. Can I write like this? The number should be of the form 5 power 2 plus k into 2. Now if you see 5 square common. To get 100, it should have power 2 square as 2. But I require only by 50. So take the power of 2 as only 1. So 2 into 5 power 2 plus k. Just take it out. K value 0. 2 into 5 square. 25 2s are 50. Divisible by 50. K value 1. 2 into 5 cube. 125 into 2. 250. Divisible by 50. K value 3, 5 power 4. It cannot be divisible by 100. Why? Because to get 100, I need to get power of 2 as 2 and power of 5 as 2. So you need to have 2 into 5 power 2 plus q. That means power of 2 is fixed to 3. There is no condition. 3 power 0 to 3 power 8. Power of 5 should start from 2. 5 square and 5 cube. So answer is 9 into 2 into 1. 9 into 2 into 1. How many factors are divisible by 50 but not by 100? Any factor which is of the form 2 into 5 power 2 plus q. 50 is 5 square into 2. 100 is 5 square into 2 square. 5 square. To get 50, I need to have 5 square into 2. Are you all with me? To get 50, 5 square into 2. Now, if I keep k plus 1, it will be divisible by 100. So, it can be 5 power 2 plus k. 5 power 2 plus k. I hope the idea it is clear. Similarly, divisible by 12 is 2 square into 3. Divisible by 18 it is 3 square into 2. 3 square into 2. Now, I need to get divided it by 12 and I should not divide it by 18. So it is, now see here, to get 12, it is 2 power 2. Now, where should I add k? Suppose if I add 1 plus k, k value 1, 3 square into 2 square, it will be divisible by 18. So k should be added here. The number should be of the form 2 power 2 plus k. 2 power 2 plus k into 3. Divisible by 12 is of the form 2 square into 3. Should I add k here, k here? That is the doubt. If I add 1 plus k, it will become k value 1. 3 square into 2 square. It will be divisible by 18. So 2 power 2 plus k into 3. So 2 power 2 plus k. How many combinations? 2 square into 2 power 7. 3 power 1 is fixed. 5 there is no restriction. 5 power 0 into 3. 2 to 7, 6 values into 1 into 4. 6 into 1 into 4. Answer is 24. 2 square into 2 power 7. It is 6 cases into 1 into 4. 6 into 1 into 4, 24. I hope the fundamentals class on factors, it is clear. Divisible by 50 but not by 100. Perfect square always has odd number of factors. Some questions based on it. If a number has got odd number of factors, 2k plus 1 will be a factor. 1 less than root 10, k greater than root 10. Why a perfect square will have always odd number of factors? Reverse is also true. How to find out the factors which are perfect squares? How to find out the factors which are perfect cubes, non-perfect square, non-perfect cubes? Next one, how to find out the factors which are of the form 4k, 4k plus 1, 4k plus 2, 4k plus 3, 3k plus 1, 3k plus 2. Factors, odd factors, even factors. How many factors are not factors for another number? How to find out the HCF, lowest power of the common prime basis? How many numbers will have only 2 factors, only 3 factors? How to find out the factors which are prime and which are composite? Which are prime and which are composite? I hope all these definition of a prime number. Definition of a prime number. So what are all the concepts which we discussed? We discussed factors and we discussed, still we are in factors. The complete point number 1 we completed. In the next class, we will try to solve all the problems related to sum of the factors and product of the factors, sum of the factors which are multiples of k, sum of the factors which are not multiples of k, sum of the reciprocal of the factors, sum of the factors which are perfect squares, sum of the factors which are not perfect squares, definition of a perfect number, a question based on a perfect number, similarly product of the factors. In detail we are going to discuss. I will again meet you at 2 o'clock. We will try to complete point number 2 and point number 3. Thanks a lot for watching the first class. With love, Anil Nair.